Hello, dear students. Proposition 7 of Book 3. If in a circle, a point be taken which is not the center of the circle, and from that point lines fall upon the circle, the circumference of the circle, the line which passes through the center of all those lines falling upon the circumference, starting from that point which is not the center of the circle, of all those lines, the greatest will be that line which also passes through the center of the circle on its way to the circumference, say. And the least line will be the remainder of that very line. I'll show you in a second. And of the rest, the lines falling upon the circumference, those which are closer to the greatest are always greater than the more remote from the greatest. Okay? That's the first part of the proposition. And the second part of the proposition is that of all those lines which fall upon the circumference, anytime you pick one of them, there can only be one other equal line on the opposite side of the circle. That will be equal to it. There won't be two, and that's it. Only one line will be equal. We're going to do it in two ways, okay? So let's start with the first one. Here's our circle, and here's our point, not at the center. Let this be the center. Okay? And let's draw lines falling upon the circle, the red one, the blue one, the black one, okay? And the black one gets dashed right as it starts passing through the center. And let the remainder of this black one be green right here, okay? Thus it is required to show that this line from that point, this line which passes through the center is going to be the greatest. This line, which is the remainder of the whole line passing through the center, is going to be the least. And of the rest, the closest, that this red one will be greater than the blue one because this blue one is more remote from the greatest than the red one is. Okay? And then later we're going to show that second part of the proposition. Okay? So let's have some fun here. Let's connect from the center. Let's connect these 2 points. And then let's connect from the center these 2 points. Okay? Now, let's call this the red triangle, let's call this the blue triangle. Okay? And this will be the angle right here of this red triangle, and this will be the angle of the blue triangle. Great. So let's start off by showing that this one is greater than this, and this will be greater than this, and this will be greater than this. Okay, so look at this triangle here. We have two sides in any triangle are always greater than the more remote. So this plus this in this triangle is greater than this. Did I say greater than more remote? Two sides taken together are greater than the third side. So this side plus this side are going to be greater than this side in this triangle. But this is equal to this because they're radii of this same circle are coming from the center. So this plus this is going to be equal to this plus this because this is in common. So if this line is equal to this plus this line, and this plus this line are greater than this line is also greater than this line. Two things equal to the same thing are greater than each other. If this is equal to this and this is greater than this, this is also greater than this. Great. Now, let's show that this is greater than this. Okay, here's a triangle, and here's a triangle. I've got two sides equal to two sides in this triangle. Why? Because these are radii of the same circle, so they're equal, and this is in common. So this and this are equal to this and this. So here we have two triangles with two sides equal to two sides, and one of those two sides is containing a greater angle than the other of those two sides. So as we know, if you have two triangles such that two sides are equal to two sides and one angle is greater than the other, the base of that greater angle, opposite that greater angle, is going to be greater than the base of the triangle opposite, the line opposite the lesser angle. So this and this and this and this are equal. this is greater than this. So here you have two triangles such that two sides are equal to two sides, one angle greater than the other. So the angle with the triangle with the greater angle is going to have the greater base than the triangle with the lesser angle. So this is going to be greater than this. Great. And if you had a bunch of lines, you keep doing the same thing. Now we need to show that this is less than this, or whatever line you end up falling upon. Great. So we've got this and this being radii of the same circle, so they're equal. This is equal to this. Now, this and this in this triangle, this and this are greater than this, because in any triangle, two sides are always greater than the third side. So this plus this is greater than this. So therefore, this plus this is also greater than this, because this is equal to this. Got that? This and this are radii of the same circle. This and this was proven greater than this. So this and this is also greater than this. Okay? So this and this is, this and this is greater than this. This is common. Let's take that out. The remainders will be equal. Therefore, this will be greater than this. Did I say equal? I don't remember. Let's do this and this are greater than this. This and this are greater than this. Therefore, this is greater than this because we take out the equal part. Okay? So that's it. We showed that the line from that point, the line passing through the center is the greatest. The remainder of that line, when taken to the other side of the circle, is going to be the least. And those which are more remote from the greatest line are always going to be less than the closer to the greatest line. First part of the proposition. Let's do the second part. Same circle, same point, and we're going to show that there can only be one line drawn on the other side of the circle that will be equal to that one line. Okay? When the angles are equal. Oh, sorry, even if the angles aren't equal. So let's take an equal angle here. Let's go here. And then, as we know, in any angle, we can always draw a line equal to that. We can always draw an angle equal to that angle. So let it be this. So this angle is equal to this angle. Great. I say that this line is equal to this line. For if not, let it one of them be greater, let this one be greater, and let's cut from the greater. This one, a line equal to the lesser by Mr. Smarty Pants' idea. Okay, so now we want to connect. How do we want to do this here? I guess connect. I'm going to try to make this up as we go along here. Connect this and connect this. Yeah, that might work. And then connect this here. Do it with red. Good. So we have these two triangles. Look at this one and this one. And we've got two sides equal to two sides. This is in common in these two triangles. And this was cut equal to that, say. So this and this are equal to this and this. And the angle they contain are are equal. They were drawn equal. So therefore we have two triangles, two sides equal to two sides. And those two sides contain equal angles. Therefore the base is equal to the base. So this is equal to this. Great. But look at this. This comes from the center, this comes from the center. Therefore, the radii of the same circle, therefore this is equal to this. So I've got this equal to this, we've got this equal to this, and this equal to this. Two things equal to the same thing or equal to each other. Two things equal to the same thing or equal to each other. Therefore, those things are equal. This is equal to this. But they're also not equal because this is the part of this. We know that the part is not equal to the whole, it's less than the whole. So I've got this being equal to this and being not equal to this at the same time in the same respect. That's a real problem. So the thing we granted at the beginning that this is not equal to that is false. Likewise, there will be not any other line drawn from that point equal. It can only be one line. Why? Because we've already shown that if there be a point on a line, in a circle, a point in a circle, the line passing through the center is going to be the greatest, and those most further from the greatest are going to be less than the more remote. So if this equals this, according to Mr. Smarty Pants, And we showed that this equals this, two things equal to the same thing or equal to each other. So this is equal to this. But it's also not equal because this is more remote. So this is, in that case, would be equal and not equal to this at the same time in the same respect, which is absurd. So it cannot be the case that this is equal to this, nor can there be any other line drawn over here being equal to this, because we'll have the same absurdity following. So, therefore, there can only be one line drawn equal to that other line on the other side of the circle. Okay, quod erat demonstrandum. Therefore, if there be a circle, and a point be taken in that circle that is not the center, and then you let lines fall upon the circumference of the circle, the line which passes, of all those lines, the one that passes to the center will be the greatest, the remainder of that line will be the least, and of all those other lines, the further remote from the greatest will always be lesser than the closer to the greatest. Further, of any of those lines, there can only be one line drawn on the other side of the circle of that diameter. There can only be one line drawn equal to the other. There cannot be two, and there is necessarily one. Quod erat demonstrandum. Thank you. Bye.